Hi, junior high. Last lesson of the week. 1-9 inverse variations. Don't have a ton to say about this one before we get into it, so I'll just get going. Objectives: determine whether a relationship between two variables is an example of an indirect variation by checking to see whether they have constant product. Use the formula for indirect variation to solve word problems. We've worked with direct variation earlier in the year, and we'll look at that here in a second. Vocab inverse variation is the relationship between serving size and the number of servings. So that's valuable when you're working on something like that. Direct variation. Remember, direct variation when we used it before was y equals k times x. Well, how do they get there? Is they just divide both sides by x. They get y over x equals k, which is how we get right there. Okay? Now, inverse variation is going to be the inverse of it, which is instead of dividing, we're going to multiply. So right here, we would have been dividing on this side right away by x, so then we'd have to multiply by x to both sides to get it to what this is right here. Okay? Okay. Trin travels 120 miles to visit his friend. If he averages 60 miles per hour, then the trip takes 2 hours. What is the quality or quantity that remains the constant in the problem? Well, our time's going to change depending on how fast we're going, right? That's going to depend on how long it takes there. But no matter what, we are still going to travel 120 miles. So your quantity that remains the same or constant in this problem is going to be the number of miles you travel, which is 120 miles. Fill in the chart with the possible rate and times combined. So for B, if I'm driving 120 miles and I do it at 40 miles an hour, it's going to take me about 3 hours, right? Okay, and I brought up serving size. Well, let's say I have enough to, let's say 40 pieces of candy is a serving size, and I have a 220 pieces of candy. Well, only 3 people could have it, is how it's going into that. If we have 120 miles to go and I'm driving at 30 miles per hour, it's going to take me 4 hours. Okay, and 120 divided by 20 would get me 6 hours. So, there's our chart filled in. Show that the rates and times for Trin's trip are inversely proportional. Well, if you multiplied this back out, 2 times that would, or 2 times, so if you multiplied here, you get 120. Multiplied here, you'd get 120. Multiply here, you're still going to get 120. Multiply by this, you're still going to get 120. So, and we could show that. I explained it better than I wrote it down. But that's basically doing the inverse. By using what we already know to go backwards to figure out how far we actually traveled. Okay? Robert. Oh, wouldn't even be. Robots are programmed. I don't know. Figured it was a name. Robots are programmed to assemble widgets on assembly lines. The number of robots working N and the amount of time it takes to assemble a fixed number of widgets are inversely proportional. If it takes 10 robots 8 hours to assemble a truckload of widgets, how long would it take 20 robots to assemble the same number of widgets? Okay. So it says number of robots, which is n, and the time it takes to assemble the fixed number of widgets are inversely proportional. So times t equals widgets. Okay, so in this first one, 8 times or 10 times 8 equals that many widgets. Well, this number is going to be the same, so whatever this took, this was 80, is going to be equal to 20 robots times how long it takes them. Take 20 divided by h, which this should have been t, my bad. T equals 40 or 4 hours. Okay. It takes 20 robots 4 hours to complete theirs. Easy enough. Okay. So, describe each equation on the graph A, B, C. So I did C and D, which is a graph. You want to know if each equation graph, which we're working with graphs, has inverse variation or direct variation. Well, in this case, a direct variation is going to go up proportionally. Like here, we were going up by 2 for that. This, we were going up by speed, up by 10, 10, 20. So this one, as you can see, we weren't going up, but by time, we were. And that's when we were finding time. So, I would say this one is going to be direct variation. Now, one thing you can think of, direct variation. The reason this one would be direct variation is, look at this. It looks like everything, no matter what you put in there, it's at a constant rate, which means it's directly in line with the last one. This is not going to be the case. So that's why I'm going to go with inverse variation. Okay? Yeah. That's the main thing there. If it takes 3 people working at a constant or an equal rate 5 hours to complete a job, how long would it take 5 people to complete the same job? Well, 3 people times 5, because it'd take, honestly, if all 3 of these put in 5 hours, that was a total of 15 hours for the whole job. And then you have 5 people doing that job. So time divided by 5, t equals 3 hours. Okay? Oh, you can't see that. Okay, now. And I tried to zoom in so you guys could see a little better. Homework. I went to evens. We'll go 17 through 25 all. We'll change that. So scratch that. We're going to go to that. Okay?